There we go. All right. It says we're recording, so I hope we are. Well, welcome back to campus, all of you who are here in person and those of you watching on the video. I hope you guys are doing well as also. And today we are going to start talking about object-oriented programming. And so today we will cover S3. Wednesday we'll cover R6. Anyway, let's look at this. So what is object-oriented programming in the first place? Well, it's a style of programming, and it's centered around this idea of defining different types of objects. And then we also have functions that can be applied to those objects. These are the things that the objects can do. R's object-oriented programming system is a bit wonky, okay? You end up having 4 different systems that all kind of implement some kind of object-oriented stuff. You got S3, you've got S4, you've got RC for reference class, and R6. And well, we'll talk a little bit about we'll talk about S3 and R6 as S3 is the most important one, and then R6 is probably the elegant solution for encapsulated OOP. All of my stuff is coming from Hadley Wickham's textbook, which covers the subject. He also covers S4 in detail, but I'm not going to get into it, okay? S3 and S4 implement what's known as generic function object-oriented programming, whereas RC and R6 use encapsulated object-oriented programming. And right now, probably that doesn't mean very much to you, but in all of these systems, the objects store information, and everything that we do to interact with objects are called methods. Those are the functions. So if you've ever learned another programming language, say Python or C++, and you did object-oriented programming there, that was most likely encapsulated OOP. And you might have even learned about encapsulation as being kind of this core principle of object-oriented programming. And for those systems, absolutely it is. And in encapsulation, what that means is that everything is encapsulated within the object. All of the values, the fields, the data are stored in the object, also the behaviors, okay? And so you can think of some camera class object, right? So you can think of an object that's a camera, and it might have information to store, such as how many pictures have been taken and how much memory is available. And these are bits of information from the camera. The camera also has methods, such as, these are the verbs that we use to interact with the camera, such as shoot a photo, okay? Or focus your camera, or record a video. These are verbs that we can do when interacting with a camera. And we do have encapsulated OOP via R6 and RC and R, and we'll talk about that on Wednesday. Today we'll look at S3, which is a generic function OOP system. In generic function OOP, the objects or classes, they store data in fields, but the objects don't contain methods, okay? Instead, the methods belong to the functions. They belong to generic functions, and the function will look at the object being given to it. It will figure out, hey, this is the class of this object, and this is the appropriate thing to do. So for example, if think of the verb shoot, all right? And what does that verb shoot mean? Okay, well, it means different things depending on what you're talking about. So if I hand you a camera and I say shoot it, you're going to take your camera, point it at something, and take a picture. If I hand you a hockey puck and I say shoot it, you're going to hit the hockey puck towards the goal, probably with a hockey stick. Okay? If there's a gun, okay, shoot would mean pulling the trigger, aiming at a target and pulling the trigger. And you can also shoot the breeze or something, and that would just be to chat idly about something else, right? And so in generic function, OOP, the function or the verb behaves differently depending on the object. And so these types of functions, these generic functions, are known as polymorphic functions, and that's because they behave differently depending on the input type. So S3 and S4 use this generic polymorphic function system, and as far as base R, everything is done via S3. So here's an example of a polymorphic or generic function in R. So we have the diamonds data set. The diamonds data set is this big data set, comes in the ggplot library. It's got information about the clarity of the diamonds, the cut of the diamonds, carat diamonds, things like that. It's got like 50,000 rows or something, okay? So notice we call summary on diamonds $carat. We look at the carat column in the diamonds data set. The carat column is numeric. It says how big is the diamond, okay? Some diamonds, the smallest one is 0.2 carats. The biggest one was 5.01 carats, okay? A lot of, the median size of the diamonds is 0.7, things like that. And when you call summary on a numeric column, what does it do? It gives you back the 5-number summary plus the mean, okay? So basically a 6-number summary, I guess, right? Okay, look at the cut column. Diamonds $cut. The cut is a categorical variable. It's an ordered factor, okay? With the highest quality cut being the ideal cut, and the next highest grade would be premium, very good, good, or fair cut, okay? And when you call summary on a factor like that, what does it do? Well, it doesn't try to calculate the mean or the median, because you can't really do that with a categorical variable. But what it does is it gives you the count of each of these cuts. So it says there's 21,551 diamonds with ideal cut, 1,610 with fair cut, and so on and so forth. So it gives you the a tally of each of these things. In both cases, we call the function summary, okay? So that function summary behaves differently depending on the variable that we give it, right? So depending on whether we give it a numeric variable or a factor, the output is different. Now, this happens all behind the scenes. You probably don't even think about it, right? You just call summary, and it gives you some summary information. If you are currently enrolled in 101A, or if you've already taken 101A, you've created linear model objects, right? You say, y tilde x, and you create a linear model object, and you'll often call summary on that linear model. And what does it output? It outputs like this whole table of like the coefficients and the t statistic and p-values associated with each of those coefficients. It does that even though you're just calling summary. The same function summary behaves differently depending on what you've given it. Okay, so how does it work like this, right? Well, it depends on classes. We need to define the class of an object, and the class will contain different kind of fields that are specific to that class. And then we've got a method, which is an implementation of that specific class. So a class defines the object. The method describes what the object can do. A lot of times classes are organized in some kind of hierarchy. And so we have this concept of inheritance. So if you have like a child class and a parent class, the child class might have like specific versions of functions and methods that apply to that thing, but you might not have to redefine everything all about all of these things. And so that child class will inherit from the parent class. So for example, we have an ordered factor. An ordered factor is pretty much like a factor, except the levels have a specific order applied to them, right? It's kind of like a t-shirt size, small, medium, large, extra large. And we should preserve that order rather than putting things in alphabetical order or something like that. And so, but other than that, an ordered factor behaves just like a factor. So we have a few methods that are specific to the order, the ordered factor. And then, but then pretty much for everything else, we can just say behave like a factor, and it'll inherit from a regular factor. Okay, a tibble inherits from a data frame. It behaves like a data frame in most situations, but when it comes to printing things out on the screen, it does a few things a little bit differently. So how does R figure out what method to use? Okay, this is done in a process known as method dispatch. And generic functions, we call generic functions like summary or print or plot. And within that is code to determine what is the appropriate method to use. Okay, so the generic function determines the class of whatever object is being passed to it, and then it will select the appropriate method. Okay, so once again, we have 4 different base types, or 4 different object-oriented systems. We have S3, S4, reference class RC, and R6. R6 is not part of base R. You have to call library R6. But S3 is kind of the simplest, most flexible object-oriented system. Everything in base R and the stats package and is done in S3. Okay. Now there are there's some weird things that happened in S3 because it's not strict at all. Okay, S4 is kind of like S3, but it becomes a lot more strict and it has heavy rules and won't allow you to do some of the funny things that you can do in S3. Reference class will do object-oriented or message passing object-oriented programming. So in those cases, the methods belong to the classes, not to the functions. And R6 is also like that, except it's a little bit more elegant. And in our class, we'll just look at S3 and R6. There's also base types. Base types, we're, I think, familiar with this, but pretty much all of the OOP stuff, especially S3, is all built out of base types. So we take kind of these base type structures, which are actually coded in C, and we build our OOP objects out of these base types. Okay, let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is D as in dog. D as in dog is your first view quiz answer. All right, so base types technically aren't considered object-oriented systems, and only the R core team can create new base types. So we don't regularly see new base types. Most of your, all of kind of your normal stuff that you interact with are generally base types. So things like your atomic vectors, your doubles, your numeric, double and integer and logical, all of those things. Lists are base types. You also have functions and environments. Those are base types. And then there's some more exotic objects like names and calls and promises. And you can find out the base type with type of. Unfortunately, the naming system is a little bit weird. So you've got, like if you call type of on the function mean, you get, it says it's a closure. But then you can ask, is it a function? And it's going to come back as true. Whereas the function sum is known as a primitive function. But if you ask type of on sum, it's going to come back as built-in rather than primitive. So anyway, don't worry about it. Even if you don't ever write C code and stuff, it's helpful to just understand that a lot of our object-oriented systems are built out of these C code base types. S3 objects can be built out of any base type. S4 objects use a special base type, And reference class objects are a combination of S4 and environments, which is another base type. The difference between base and object-oriented objects is that object-oriented objects will have a class. So when you call a class, which is basically just a field in the attributes list, it's going to have a class defined. And you can check to see if something is a base type by just asking, is it an object? And if it doesn't have a class attribute, his object will return false. Okay, let's take a look at the S3 object-oriented system. Okay, most of the objects you encounter in R will be S3. Okay? There's not a simple way to test for S3 objects. You call is.object. That has to be true. It's got to have a kind of a class in its in the attributes, but it can't be an S4 object-oriented system. And we have a question for it asking, is something S4? But that needs to be false for it to be S3. Okay, so here's an example, right? Let's create a data frame. Data frame X 1 through 10, Y letters 1 through 10. We ask, is it an object? A data frame is an object. It's built out of a list. The base type is a list, but when you print it out, it looks like a table. It's a data frame, and that's an object. Is a data frame an S4 object? It's not. Okay, it's an S3 object. We look at the variables inside the data frame. The variables inside the data frame are just atomic vectors, right? You got df $X, is that an object? That comes back false. df $Y. It's also just a character vector, so it's not an object. However, if I said y is a factor, right? If I made y to be a factor is an S3 object, okay? Factors are built out of integers, integer vectors, and it comes with extra attributes, the levels attribute and the class attribute, and that's a factor, and that's an S3 object. So once again, when we talk about the methods in generic function OOP, which S3 is, the methods don't belong to the objects, okay? The methods belong to the generic function. And you can, all the functions that are generic functions in R, when you ask for the definition of the function, which you can do just by typing in the name of the function without the parentheses, anytime you type in the name of the function without the parentheses, it will give you kind of the code written inside the function. If you type in mean with no parentheses, what you're going to see is the definition of the function. It says function, use method mean, and that's the entirety of the code. Use method, anytime you see that, that means it's a generic function, and it's going to do method dispatch. It's going to look for methods associated with mean. So there's other internal generics. So there's a few exceptions to that thing I said about the generic functions using use method. There's a few internal generics such as the subset function and sum and cbind. These are internal generic functions. Those are written in C. But other than that, most of the time, whenever you have a generic function, it's going to be use method. You're going to see use method. Okay? Only in the kind of just a few cases where you have the internal generic. When you're given a class, the generic function, what it's going to do is going to find the correct version, right? So when we called summary on that numeric vector, it needed to find how to find the summary for a numeric vector, right? When we called summary on a factor, it needed to find how to find the summary for a factor. And all of those things are done by kind of the way we name functions. So functions, the actual function being run is going to be something like mean dot, I'm having trouble highlighting this, okay? Mean dot date, okay? So if you have a date class object and you call mean on it, it's going to look for the function mean dot date. If you have a factor object and you call print on it, it's going to look for the function print dot factor. And all of them are in this form of generic name dot class, right? So it'll be like summary dot data frame, summary dot factor, summary dot something else, summary dot lm. And because we use the dot to name all of these methods and stuff, we discourage the use of dots in variable names these days. All right, so most style guides will say use an underscore if you need to have a space or something rather than a dot. So for example, there's a function called t-test, t.test. You might have used it. And the way it's written, it looks like it's the function t for transpose applied to a test class object. Now that's not what's happening. It's its own kind of generic function where it's going to perform kind of a two-sample Welch t-test where you compare the means of things and you calculate a p-value and stuff like that. But the way it's written, t.test, it looks like it's going to call the t function applied to a test class object. Okay. Similarly, you got print for a data frame, data.frame class object. And the method for that is print.data.frame. But the way it's written, it's a little ambiguous. It could be print for a data.frame, okay, which is what it is. But somebody else could look at it and say, is it a print.data function for a frame class object? And technically, it would look like that as well, right? If you did have a frame class object, and if you did have a function called print.data, it would look like print.data.frame. So it looks a little strange there. But so most of the time we say use an underscore, so read underscore CSV as underscore Tibble to avoid this kind of confusion. There's a library called Prior, library PRYR, all right? And this will help you look up generic functions and things associated with this. Now, to be honest, I never use this library, okay? I only call this library for this lecture that I can explain about methods and classes and things like that. But that's probably the only time I ever use this in real life, okay? Other than that, I never use this library prior, but as far as exploring methods and things like that, it is helpful for that. So we can ask t-test. Is t-test a S3 generic? That's actually true. And we can call, what are the methods associated with t.test? Okay, the methods associated with t-test is there's the default t-test, and then there is the t-test applied to formula class objects. All right, and so in R, you can call functions with the formula format. The formula format is, y tilde x, stuff like that. Y tilde x plus x2. Okay. And so t-test is actually a generic function. And again, you can tell it's a generic function by putting in the name of the function, no parentheses. And when you hit enter, R spits back the definition of the code. And inside the definition of the code, we see use method. Use method. That's kind of the key indicator there that we've got a generic function. Whereas we have t.data.frame, that is not a generic function. t.data.frame is the transpose function applied to a data frame class object. Okay. If we ask, is it a S3 method, that comes back true. It is the transpose method for the data frame object. We can ask, what are all the methods associated with a certain generic function? So we can say, well, what are all the methods associated with the function t? And we see there's methods for data frames, the default transpose. There's a method for gtable, a method for ts time series, method for, I don't know, vectors, underscore scalar. I don't even know what that is, but it's something. So let's just see what happens, right? So here I create a matrix X. It's got 4 rows, matrix consisting of the numbers 1 through 12, 4 rows, and I say transpose X. And I transpose it, it gives me back a matrix now with 3 rows and 4 columns because we transpose it. Here, I've got a data frame, DF. Data frame has 3 columns. Column A, which has 1 through 4, column B, which has 5 through 8, and column C, which has 9 through 12. And I say, let's transpose the data frame. When I transpose the data frame, it gives me back a matrix, 3 rows, 4 columns. Okay? Now, to the user, this doesn't seem like that big of a deal. This is, it comes back 3 rows, 4 columns. This comes back 3 rows, 4 columns. It doesn't seem all that weird. But internally, think of how is a matrix stored and how is a data frame stored. Internally, a matrix is stored as an atomic vector with dimensions, whereas a data frame is stored as a list. Right? And so when we call transpose on a data frame, the internal code that has to run is actually quite different. The internal code that runs for transposing a data frame is quite different because the data frame is actually stored as a list. And so we have to kind of convert that list structure into basically like a matrix structure first, and then we can transpose it. But internally, that kind of stuff has to happen. Now, to the user, the whole point of object-oriented programming is to make it easier for the user when they're writing their code and their scripts and things like that. We don't want the user have to think and say, oh, you know what, this is a data frame. Internally, it's stored as a list. So when I call transpose, I got to actually think of a way to go through this and stuff. That can become a pain. Okay? Both of these functions pretty much behave very similarly, and the user generally probably doesn't even have to think about it. Okay? But internally, what's happening? Well, the first time we call it, it's being done on a matrix, and that's kind of the default behavior of the transpose function. So t.default actually uses kind of the internal generic function, and it transposes the matrix. So that there's like C code written to kind of swap all of these index positions. Okay? Where when we call it on the data frame, it actually, before it can run the transpose, it's got to convert X into a matrix first, right? And this as.matrix, we don't see the code, but it actually, you know, there's a bit of work there to do, right? Because it's internally stored as a list and it's got to convert it into a matrix. It stores it, and it takes the data frame, turns it into a matrix, and then it can transpose it, okay? Let me give you your next view quiz answer. Next view quiz answer is C. C as in cat. C as in cat. All right, so again, you can ask, what are all the methods that belong to a generic function? You say methods and you give it the name of the function. So these are all of the different methods that belong to, say, the mean function. We got mean.date, mean.default, mean.difftime, so on and so forth. What are all the methods associated with t-test? And we can do that. You can also ask, what are all of the methods associated for a certain class? So I'd say methods. What are the methods associated with a time series class object? Class equals TS. And we have all of these methods. Okay, we have the subset. We have the subset along with assignment, right? So you can subset something and change the values in that thing. You've got aggregate, as.data frame, as underscore tibble, cbind, coerce, cycle, I don't know. A bunch of stuff that can be done with a time series class object. Okay, let's talk about defining our own classes. Okay, the S3 system is kind of an ad hoc system. There's no formal definition of a class. You can just create an object and then assign a class to it as you create it or after the fact. So one way is you can use structure. And so here I'm going to take a base type, a list, put in the string apple, and then I'm going to say the class of this object is a fruit class. This is going to be object X. Another way I can do it is I could create an object Y. It's going to be a list containing banana. And then after creating Y, I can just kind of change the class after the fact. And I can say assign fruit to class Y. So I can do this after the fact as well. Okay? And this creates and defines a new S3 object class called fruit. And it's simple as that. Very easy to do this. we can ask, okay, well, what is the class of X? What is the class of X? R comes back and says, yeah, it's the fruit class. We can also ask, does X inherit from fruit class? And that comes back true. Okay? All it's doing is remember, we can have attributes. Objects have attributes, which is just a list with just any information you want to put into it. And here, just inside the class part of that attributes list, we just put in the word fruit. Okay. Objects can have multiple classes. That class attribute can be a vector with multiple values. And that's useful anytime you have inheritance. So for example, diamonds is a tibble. The class attribute in diamonds is actually a vector of length 3, tibble underscore tf, tibble and data.frame. And that means that diamonds inherit from data frames, inherits from tibble, and inherits from tibble underscore df. Diamonds $cut is an ordered factor. And that, when we ask what is the class there, it gives me 2 values, ordered or ordered factor. And then it's also inherits from just regular factor. When you want to check to see if an object belongs to a certain class, probably the recommended method is to use inherits. So I could do inherits is that column cut in diamonds data set, is that a factor? So I do inherits diamonds $cut factor, right? And that's going to return true. And it's going to say cut is a factor, it inherits from factor. Now, why can't I just do class equal factor, right? I could, but it might not be the answer I'm expecting. Because when I say, because a lot of times we can say, hey, is the class of diamonds cut, is it a factor? And what we picture in our mind is class diamonds $cut equal factor, right? It's a reasonable thing to think. But what do we get? We get back false true, okay? Because remember, the class of diamonds $cut is this vector, ordered factor, okay? And so the first value, ordered isn't equal to factor, so that's going to come back false. The second thing is a factor, so that comes back true. So it might be more useful if you wanted to do class diamonds $cut equal factor, you got to keep in mind that the class vector could actually be a vector longer than 1, and you can do any or something like that, okay? Or any of the values true. Then that would summarize it to just 1. But probably inherits. Inherits is the recommended way to check. Whenever you create a new class in R, it's recommended, it's not required, but it's recommended that you create a constructor function. Pretty much all of the other S3 objects in R come with constructor functions. A constructor is just a way for a user to create new objects of that particular class. For example, we have constructor functions like factor and constructor functions data.frame. And whenever you call factor, it's going to create an object of class factor. When you call data.frame, it's going to create objects of class data.frame. So for example, if we wanted to create a constructor that's going to create objects of class fruit, here's a simple way to do it. Okay? We can just say, hey, create fruit out of whatever you put in X. We're going to first just make sure X is a character vector. So we're going to do is.character, and then we're going to do stop if it's not. Stop if not is.character. And then what is it going to return? It's going to return an object of class fruit. Okay, we call structure on list X class equals fruit. So here I'm going to create a new object called Z, and then I'm going to call the fruit constructor, pass it the string pineapple, and now I get pineapple object class fruit. Now, with S3, you can just change the class of an object. The class of an object, again, is just stored as kind of a label inside the list attributes. So when you create a linear model object in R, it creates an object of class LM. So here I said LM log of MPG as explained by a log of displacement. So we're going to try to guess a vehicle's gas mileage based on the size of its engine, right? So you got big engines and little engines. In general, smaller engines get better gas mileage. Okay, we can ask, and it returns an object of class LM. And whenever you print a linear model object, this is kind of what it prints out. It gives you the call along with some coefficients, stuff like that. So when you call print on this, it gives you this. Now watch what I do. I'm going to just say, hey, let's change the class to data frame. Okay, you shouldn't do this. This is a bad idea. Okay, we're going to just arbitrarily I'm just peeling off the label, right? It was labeled LM. I'm peeling off the label and I'm putting on a new label, data.frame. And the computer says, oh, it's a data frame. And then we say print this data frame out, and R doesn't know what to do. I mean, it tries, it did its best, okay? And it says, you got 0 rows in here, right? And it looks like all of the information is disappeared. It hasn't though, the information is still there. It just doesn't know how to print it out. So if I call LM $ coefficients, LM empty cars $ coefficients, the coefficients are there, okay? The values are still there. All we've done is we've just changed the label. We've just changed the label. And again, the computer just looks at the label and says, okay, well, I need to treat it this way. And then it gets confused, right? It's kind of just like at the grocery store, if you peel off, one of the stickers from one fruit, you can peel off the banana sticker and put it on top of an avocado or something like that, right? And then, I don't know, maybe you can check out and get an avocado for 19 cents. That's stealing, don't do it. But the computer doesn't know any better, right? It just sees, oh, here's the label, beep, okay? Here's your, $2 avocado for, 29 cents, okay? But, so it's treating it like a banana, but it doesn't know any better, okay? If you had in the house of the future where you buy your fruits and, I don't know, it sorts it or something, and you say, hey, I want a banana smoothie. Well, it's going to grab that avocado because it's got the wrong label, okay? It's going to get confused. So, don't do this. This is a bad idea. But R is not going to stop you, at least in the S3 system. In the S4 system, it says, we don't do that, okay? The S3, it just says, okay, sure. You want to change the label, you can do it, right? So the lack of built-in verification has potential to be problematic, rarely causes issue in practice, right? So while you can change the class of an object, you never should. R is not going to protect you from yourself. Okay, let's talk about methods and generics. So the generic function is purpose of the generic function is to perform method dispatch. Okay, and all of these things use this function, use method. Okay, so here I'm going to create a function called quotation. Okay, this is going to be the generic function. We're going to say, give me a quote for this type of object. Okay, and I'm going to define my own methods, but I'm defining my own generic function called with use method quotation. And the way it's going to work is when it searches for functions, we're going to look for certain types of functions. So I'm going to define a new function called quotation.fruit. This is going to be a method of the quotation generic, which is going to get used when we give it a fruit class object. And the quote is, fruits are an important part of a balanced diet. Okay. All right. So we're going to create an object X. X is going to be a banana in the list with class fruit. And if I say, give me a quote on object X, it's going to come back and say, fruits are an important part of a balanced diet. It has looked up this function. This function just returns this quote. That's all we get. You can also add methods to existing generics. Okay. So if I called mean, probably it would come back with an error and says, I don't know how to take a mean of this list with banana in it. What's the mean of banana? That doesn't even make sense. Okay. But we can say, you know what? Let's make a function, mean.fruit. Okay. Whenever you see a fruit class object and ask for the mean, this is what I want you to do. I want you to tell me the number's 5. You go, okay. R says, all right. So let's ask, what is the mean of this banana, which is a fruit class object? It comes back and it says, The mean is 5. That's what you said. Therefore, it is. Okay. Again, there's no check to make sure this even makes sense. It doesn't make sense. What's the mean of banana? 5? No, that doesn't make sense. The more reasonable thing would have been to say, I don't know what you're talking about. But here we said, let's just say the mean of anything dot fruit is going to be 5. Okay. Just make sure when you do this kind of stuff, you want to kind of make sure that it makes sense, right? How does the method dispatch work? Well, what it does, it just pastes the name of the function with a dot and the name of the class, okay? And if it can't find the class, it uses default, all right? So default is kind of your fallback method. So here, we'll define more methods. So we've got the generic function quotation. We got quotation.fruit, quotation.apple, quotation.default. So now we have methods for apple class objects, methods for fruit class objects, and we have a default method. So here I'm going to create an object, Fuji. Fuji is a class of apple and fruit. Okay, so we have class apple, class fruit. And so when I call quotation on this, it's going to search first for quotation.apple, and it finds quotation.apple. It works, and it gives me apple a day keeps the doctor away. That's what it returns. For the next thing, I've got Chiquita, and that's going to be class banana and fruit. And when I call quotation on this object, it's first going to look for quotation.banana. We don't have quotation.banana defined, right? We only have quotation.fruit, quotation apple, and quotation default. So it searches for quotation banana, doesn't find it, so then it searches quotation fruit.fruit. It finds quotation.fruit, and it returns the quote associated there. Fruits are an important part of a balanced diet. Okay, the last one I say we've got Dunkin' class donut, and we ask what's the quotation there. So it searches quotation.donut, it doesn't find it, so then it searches for quotation.default, finds the default quotation, which is let food be thy medicine and medicine be thy food. That's nice. Okay. So methods are just our functions with a dot in them. Okay. So when you call quotation on this banana and fruit, it's going to come back and it's going to search for a quotation of banana. It doesn't find it, and it finds quotation.fruit, and it gives you that quote. But you can say, hey, run quotation.apple. Okay, it's just the name of a function, right? And what it does is it finds quotation.apple, and even though we're calling it on the banana, it's going to come back and say an apple a day keeps the doctor away. Okay. All right. Again, this is not intended, right? This is like, I want you to. Here's a camera. I want you to shoot it, but I want you to shoot it like a hockey puck. Okay. Well, you're gonna, hit the camera with a hockey stick and break the camera. But you can do it, right? You can. It's like giving instructions, saying, I want you to treat it like this and do it like that. Okay. If you don't define the generic function, or I'm sorry, the default method. So here, I'm deleting quotation.default. Okay. So now we just have quotation.banana or quotation.fruit, quotation.apple. We don't have a default quotation.default. So now I call quotation on my Dunkin' Donut, and it comes back and it gives me an error. It says no applicable method for this thing, and there's no kind of default method. No default method. So we run into errors. Let me give you your last view quiz answer. Today's last view quiz answer is the letter A. A as an apple. Okay. There is inheritance. Okay. So inheritance, the way it works, right, is that first of all, your character class can be a vector of multiple values. Okay. And if a method isn't found for the first element in the vector, then it's going to look for a method for the next method, and so on and so forth. Okay. And a method can work by doing next method. Okay. these functions from prior, again, the library that I almost never use except for this lecture, will show you which method gets called, okay? So this means the method exists and is found by use method, the equals arrow. The single arrow is the method exists and is used through next method. And star means the method exists but isn't used. Okay, so let's just do a couple examples here. So this is all on the self quiz, which I want you guys to go through to kind of practice and learn and make sure you understand how S3 methods work, okay? So here we are going to define a function f. It's a generic function, and it's a generic function because it's use method. I define a method f.j, and what f.j is going to do is it's going to add 2 to x. I've got a method f.k, and what f.k does is it adds 10 to x. All right, so now I have an object. I call it k, and I assign the value 1 to it. So I'm going to call f on k. What is this going to return? What is the class of k? What do you guys think? Tell your neighbor what you think is going to happen. What do you guys think? No one's sure. Okay, yeah, we get an error. Okay, we get an error because if you think about what is the class of k, class of k is just type double. Okay, type double. So it's going to first search for f.double. Doesn't find f.double. It searches for f.numeric. It doesn't find that. So it searches for f.default, and it doesn't find that either, right? There's no default method associated with f, so it doesn't find anything. There's no applicable method here. Okay, so here, same code. I assign 1 to k. We are going to assign class k will be j. And now I call f on k. What is this going to return? Okay, now it returns 3. All right, and so this is what happens. So we got, it finds f.j because object k, it doesn't care what the name of the object is. It only cares what the class of the object is. Okay, so the class of the object is j. It finds f.j, and it's going to do x plus 2, which is 1 plus 2, gives us 3. And as far as the dispatch goes, it looked for f.j, it found it, it ran that, and that's why we got 3. Okay, so if I do f class on k here, this will now return 11. Okay, and it's because it finds f.j. All right, we'll wrap it up here. I gave you your last view quiz answer. I did. Okay, so we'll end here for today. Hopefully, I'll get my laptop situation figured out. But other than that, welcome back to school. Welcome back to class. It's good to see you guys. Hope to meet you at some point. Have a great rest of your day. Stay safe and healthy, and we'll see you guys on Wednesday.